So what are we looking at? What was the first 4 questions asking us to do? First 5 questions.
Rearranging.
Rearranging. So what we're looking at is rearranging. What do you mean by rearranging? I can't spell, but that's okay. We'll figure that out. Rearranging. What is meant by that? What are you trying to do?
Find out what x is.
So find out what something is. Is it always x?
No.
Why have I made it x? What do you think? What's the N or A? What's the word I'm looking for here? Starts with V or U?
Value.
Value? Yeah, I want to know what a value, but it's variable. So I want to find out what a variable is. So a variable is something that can change. Let's finish here. Something that can change, and it might be unknown to us at the start. How do we find out what a variable is? Where do we want it? In front of the equal sign. So on a side of the equals, what else must it be?
By itself.
By itself. Very good. So that's what we want. We want something by itself. Do we want it on the bottom or on the top? On the top. So we don't want it in the denominator, we want it in the numerator, if we've got a fraction. Happy with that?
Yep.
Cool. So I'm going to start with the first question because it was probably the easier of the... Who struggle with that? Don't be shy about it. I had year 12s yesterday, I asked that question, they struggle with that. Everyone all good with that?
Yeah.
That's good. All right. So, what's our first step? Get rid of the 6. Now, you're right. I want to get rid of the 6. I don't want to move it. Who would have thought move the 6? Yeah. No, I used to think that as well. How do we get rid of a 6? Why do we get rid of rather than move? Anyone know why we get rid of rather than move?
Because we want to only be left with the variable and how much.
Yep. So we want to be left with the x by itself. So we want to get this variable here by itself. When I was about your age, I used to guess. I used to move stuff. I used to guess. So I'd put the plus 6 over the other side. And sometimes I'd plus and sometimes I'd minus. Or I'd divide by 4. I had no process. I'd just move. I wanted to get the x by itself, so I'd move stuff. The reason I'm very intentional about saying get rid of rather than move, or cancel rather than move, is because there is a process to it. And if you don't follow the process, you get yourself in trouble. I can say this made a massive impact on my, not ability, but my performance in subjects. I'm from a C+ to a B+ by changing my ability with this. Because if you can't do this, you can't do lots of the things that you can't do trigonometry. You can't do differentiation. You can't do lots of stuff that you should be able to do if you can't rearrange variables properly. So it's really important. This is the most. If you want to get one thing out of this year, you're learning it right now. It's got nothing to do with physics. Cool. So I don't move. I don't just move. I cancel or get rid of. How do I get rid of that 6? Tom. Minus 6. So I subtract 6 from both sides, and I'll physically write it almost every time. Now what have I been left with? What's my next line? Nick?
4x
Yep.
equals 4.
Yep. Now what do I do? Logan. Divide both sides by 4. There's a little hidden maths convention here when you've got, because I've just got 4x. What does 4x mean?
4 times x.
4 times x, but that's one of those things that sometimes you don't know that. We just take that for granted. So that's an operation of a times. So instead of doing the times, to undo a times I, divide both sides by 4. X equals 1. Very good. So your rearranging is very, very good at that level. And for most of you, I'm not surprised. What you've done, I should have done that in blue. What you've done here is you've identified that what's the opposite operation to plus 6? Minus 6. What's the opposite operation of 4 times? Divide 4. So you're already doing the opposite operation elements very, very effectively. One thing that I'm going to suggest that you may not be doing, and you might just have done this through basically recall and practice, is a thing called reverse BOMDAS. Has anyone ever heard that before? What's BOMDAS, first of all?
I can't remember them all, but it's brackets, sometimes indices,
Yep.
BIMDAS, multiplication, divide, addition, and subtraction.
Yep, so you remember them all, okay? So it's sometimes called BOMDAS, BIMDAS, I don't care. Doesn't matter. It's all about telling us how we should solve problems. So I like to think of rearranging as sort of like solving is unwrapping the present and solving is unwrapping, rearranging is rewrapping the present. So we do it in the opposite order. So if we're going to rearrange, what do we get rid of first here? The plus or the times? The plus. So if you've got BIMDAS up on the board here, we work that way with our rearrangement. Let's go to question 3. Let's go to question 3. Probably actually, even I've made them too easy for you. You're too good. So question 3, what have we got?
4x squared plus 9 25.
Is it similar to the question we just did? What's different? Squared. Reverse BOMDAS that I should attack or try and get rid of. Which one first? Well, the 9. How do I get rid of that 9? Take 9. I always ask myself, what's the 9 doing to the x? The 9 is adding, so we take 9. Very good. Cancel on the left-hand side. What are we left with?
4x squared plus 16.
4x squared equals 16. Now, what do we do?
Get rid of the 4.
Get rid of the 4. Do I get rid of the 4 or the square root? Or squared, sorry.
4.
Why do I get rid of the 4?
Because it's the first one and the reverse.
Reverse BOMDAS. Very good. I was just making sure that you're confident with your answer. X squared equals
4.
4. How do we get rid of the squared?
Divide by 2.
Ooh. It will get you the right answer in this scenario. But is that the right process? So your answer is going to be correct. To undo a squared, so let's do a test on that. What's 4 squared?
16.
Okay, so 16. How do I get back to 4?
Divide by 4.
Divide by 4.
Or divide by the...
But I don't know what the number is now. So is there another operation I can use to get me back to 4? Square root, okay? So you've done it because you know the answer's 4, the answer's 2, so you've divided both sides by 2, which is good. It means you're thinking, but just be really aware of the fact that if it was, say, 3.7, if x squared equaled 3.7, could you have figured that out in your head? Probably not. So you need to fall back on the square root. They cancel. X equals the square root of 4, which is 2. Cool? So your maths intuition sort of let you down there, which is not a bad thing. Sweet. So that's the process we follow. Nice and easy for those questions, but when we get to question 7, look at question 7. What's different? Logan? Yep, so what's the main difference between the variables? There's multiple unknowns, correct? Does that matter? Does it matter? How we approach question 7? Damon? Exactly the same way. What changes? There's one little thing that changes. You don't have numbers? So okay, let's look at this question here, right? So let's say, I'm just going to do exactly the same question. I've got 4x plus q equals m. Is that any different? What's q equal? What's m equal? But we don't know that. Let's pretend we don't know that. We don't know that for 30 seconds. What do I want to get by? I want to get the x by itself, same as last time. So what do I follow?
Take the q away.
I take the q away. Why do I take the q? Not divide by 4.
Because it's
Sorry. Yep, so we're going reverse BOMDAS. So we can see that plus q happens before. So you're right, minus q. What happens to the q's on the left-hand side? They cancel? Yep, you're right, I got you, man. 4x equals
M make it Q.
M minus Q. How do we get x by itself now? Well, divide both sides by 4. X equals M minus Q over 4. Was that any harder? It was actually easier because we didn't need to solve. Does that make sense? So every year I teach some kids freak out when they see that there's no numbers. We can't do it. There's no. How can you do maths without numbers? M and Q can be anything in this scenario. It doesn't matter what they are. Those formulas there are the formulas you'll be using in physics. So get used to them. Sweet. That's how you find different variables. I'll give you another, what have we got, 28? I'll give you another 10 minutes on that. So 10 minutes to do the style codes, and you can work your way through a few of those. And then I'll pull you up and talk about trig or fractions.